All right, so you're back. Let's take a look at another example. Let's take a look at a quick example again. All right, so let's say we've got three vectors here. We got vector A, which has a magnitude of 40 degrees. I got a vector B, or it has an angle of 40 degrees. It has a magnitude of 8, say. We got vector B here, vector A. Vector B is equal to magnitude of 6 meters. Well, we'll put them all in meters. Vector B is 6 meters, and it has an angle of theta is equal to, let's call it negative 45 degrees. All right, or 45 degrees, the way I'd say is 45 degrees above the negative x-axis. Right, we're going, how do you do that? Well, look, here it is. Here's angle B, and I'm just making it up as I go along. I mean, what it actually, I'm not making up the mathematics here. I'm just making it up as I go along. So that's 45. All right, so let's add vector A plus vector B. All right, let's just go ahead and add vector A plus vector B. Okay, so I'll have to break A down into its components, and I'll have to break B down into its components. It's not that hard to do. Let's take vector and then add the components. Here's the recipe for it. Then add components, and that'll equal vector R. You'll find the magnitude of R and the direction, which is the direction. That's all there is to it. It's not that tricky. So here we go. So we've got A and B. So we've got vector A. So let's, what did we say it was? Had a R of 8, at a magnitude of 8 at 40 degrees above the x-axis. So I've got to get AX. The x component of A is going to equal 8 times the cosine, since we're going off the adjacent angle to the right triangle. Because here's the deal. Look, here's vector A. It's 40 degrees. So it's got an x component, AX, and it's got a y component, AY. Since this is the, and notice this is a right triangle, since this is the adjacent leg, it's the cosine of 40. AY, both of them are positive, so AY is equal to 8 sine of 40. So it breaks down to this. So you got 8 cosine 40 plus 8 sine 40. All right. Now, vector B looks like this. Even though it's attached to the end of A here, but what did we say? This was 45 degrees, but it's in this direction. So BX is equal to negative 6, because it had a magnitude of 6 meters, negative 6 meters times the cosine again, 45 degrees, because again, this is the adjacent leg. We're going this way, then up that way. Cosine of 45 plus, now it's a positive, it's going up in a positive 6 sine of 45. All right, so then all we do is just add those up. That's all we do. So I'll go, okay, it's no big deal. I'll go 8 cosine 40. I wind up with 6.12. And then the y component would be 8 sine 40. 5.14. This is my A vector. And then B is equal to negative 6 cosine of 45, which is negative 4.2, 4. And positive 6 sine of 45 is equal to positive 4. Oh, I should have known 45 degrees. Do 4. Add these up. 6.12. You add up the light components plus negative 4.24 is equal to 1.88, and 5.14 plus 4.24 is equal to 9.38, and this would be y hat, and this would be x hat. All right, now real quick, we're going to find the magnitude of those, which would be the square root of 1.88 squared plus 9.38 squared. All right. And that's 9.57 meters. Okay, now what's the direction? Theta is going to equal the inverse tangent then of y over x, 9.38 over 1.88, inverse tangent, because it's y over x, 0.38 divided by 1.88, 78.67, we'll go with 78.7 degrees. And it's positive above the positive x axis. Done. Okay? So we'll stop that one.